All right. Welcome to the 2021 edition of Pint of Science Festival, where the latest science and research discoveries are made accessible and fun. Hi, everyone. I am Maria Arisa, volunteer from Pint of Science Oslo chapter, and I will be your host for this exciting evening in which we will hear awesome sciences while enjoying a pint of beer. So get your pint and cheer with us. Our friend Barney here is telling all about what is Pint of Science, a worldwide festival to enjoy science in a relaxed atmosphere. Bars, pubs, cafes, and other public spaces, brewed by the effort of many volunteers who are passionate about science exchange. The festival takes place every year, over 3 days in the month of May, and simultaneously in many cities across the world. The festival started in the UK when two research scientists at Imperial College London organized an event called Meet the Researchers, which brought people affected by neuronal diseases into their labs to show them the kind of research they do. They thought that if people want to come into the labs to meet scientists, why not bring the scientists out to the people? And so Pint of Science was born. They held the first Pint of Science festival in 2013, and by 2014, already 6 countries joined and started to bring outstanding science to lovers of science and, of course, beer. The science beer combo is spread around the globe throughout the years, and today more than 400 cities in 30 countries carry the Pint of Science Festival. This year, the festival is carried online in many cities to avoid the spread of COVID-19. And the Pint of Science Festival could not happen without the outstanding work of many volunteers and the global coordination group. Since 2020, many chapters now carry the Pint of Science Festival in 5 cities around Norway. You can visit our website and social media to learn more about the festival in these cities. The Oslo team has been working repeatedly to bring you the best science in a sweet program over the next 3 days. Today, we will dive into the world of identification, and we'll learn how the development of new tools is helping scientists to identify and protect art and nature. Tomorrow, we will hear about radiation and how this seemingly scary emission is actually contributing to society in many ways. On the last day, we will listen about amazing topics that encompass different adventures throughout the daily science embodied by scientists. We hope that you can join us throughout the festival. And of course, this Pint of Science, the chapter Oslo, wouldn't be possible without the support of our sponsors, to which we thank for contributing to the exchange of science. Particularly, we want to thank the Academy for Young Researchers for all your support. Now, before we start with our first speaker, I would like to introduce Pravend Manimaran, who will be managing all the questions that you have at the end of the talks, and Matthew Davidson, who will be managing the quiz at the end of this night. Remember, we will use Kahoot for the quiz, and you can access it from your web browser, or you can download the app now. So let's start with the first night of Pint of Science 2021 Oslo chapter, Identification for All, Protecting Nature and Art. So now I would like to start by introducing our first speaker. Are we ready? How is everyone doing? Do you have a pint of beer? Yes. All right. So I would like to start now with our first speaker for tonight, Fabricio Andriulo. Fabrizio is a researcher in conservation science applied to cultural heritage. Fabrizio received his PhD in chemical sciences from Center for Colloid and Surface Science, University of Florence. During his PhD, he spent 2 years at the Museum of Cultural History of the University of Oslo, working with the Oseberg Burial ship from the Viking Age. Fabrizio research focused on wood deterioration due to the treatment with alum, particularly on finding strategies to retreat and preserve the collection for the future. He later became a research coordinator of the Saving Oseberg project, where he applied nanotechnologies to the creation of new materials for the restoration of this iconic cultural heritage. Today, we have the pleasure to hear from Fabrizio all about the wood objects belonging to the Oseberg treasure, the issues, and how science is helping to preserve this collection. Remember that if you have questions for Fabrizio, you can post them in the YouTube chat and he will answer after his presentation. Welcome, Fabrizio, and thank you for joining the Pint of Science Festival. Cheers.
Okay, thank you. Thank you for this nice introduction. Thank you. So, good evening, everyone. Today, I will just give you an introduction about the heritage science, what you can do with applying chemistry science to cultural heritage, and how this field can help us in understanding some problem related to cultural heritage. So this heritage science is an interdisciplinary domain of scientific study, which involve chemistry, physical, archaeometric studies, and this is for the same goal, just understanding more about cultural heritage, degradation, spot some fakes. Today, I'm going to be talking about some of the outcomes related to a Norwegian project called Saving Oseberg, established in 2014, which was funded by the Norwegian state with the aim to preserve the Viking Age wooden object from Oseberg Burial Mound. So everything started when in 1904 near Tonsberg. In this slide, you can see there is a square, a red square on the right. I don't know if you can see here, where the Oseberg ship was found by an archaeologist called Håkon Schittig and the Swedish archaeology Gabriel Gustafsson, and it consisted of a Viking ship, hundreds artifacts, textile, and even sacrificed animal used as offerings to the two buried women. So Viking Age ship burial dates around 834 was one of the well-preserved Viking age treasure at the moment. And here you can see some picture from the excavation. The archaeologist, he is Gustafsson. This is part of the ship, which is more or less 85% original. Nowadays, it's displayed at the Viking Ship Museum, and it's yeah, more or less 85% original. So when the excavation was carried out, many wooden objects were had to be restored and conserved because they had fallen into pieces, and some of them were highly deteriorated. So Gustafsson, who led the Oseberg excavation, suggested to use a method who learned from study in Denmark in 1904, which was which is the famous treatment in Scandinavia called the Alum Treatment. So depending on the wood from which the objects were made, they had to undergo different conservation processes in order to be preserved. So artifacts made of wood like ash, oak, pine were in good condition, but other objects like birch was had to be treated with something that could avoid the shrinkage after the evaporation of the water. Here you can see some picture of the sledges found in Tonsberg, and here a comparison between before wood, when the wood was in waterlogged state, and this happened when you allow the water to evaporate, becomes very small. The evaporation gives you a shrinkage of let's say more than 70% of the object. So in order to avoid this kind of size reducing, they decided to use a method called alum treatment. So the alum treatment was widely used in Scandinavia in early 90s, and indeed it was used to prevent the shrinkage and impart the strength of the object. So the method, this method consisted of immersing the object in a hot, high concentrated solution of alum, about 90 degrees for 30 hours. And this salt, when penetrated into the wood, could replace the water and counteract the shrinkage. Later, I will show you some picture that maybe you can understand better the salt recrystallization within the vessels. So, unfortunately, using this kind of method, a lot of acid were released. So the treatment itself was the problem of the degradation of this object. Here you can see the distribution, how the condition of the object nowadays. They are very brittle and they are falling apart, and they are very powdery because the alum salts are filling the vessels of the wood, and which was actually a good method to prevent the shrinkage. But the problem was that actually a lot of acid was released, and the wood, the cellulose, lignin, it's very sensitive to acids. So after the treatment, some degradation problem occurred. And here you can see some X-ray collected on this piece of wood, and the white area is the distribution of the alum treatment. Here, part of the team, the Oseberg team, who collaborated with me in the past, 6 years actually, and they are people from Oslo. There are some collaboration with Mary Rose Vasa Museum in Sweden, and we collaborating also with people from Nottingham, Wageningen in Holland, and in Pisa as well. So as I said, the reason why the object are so acidic is due to the treatment, and here you can see this is the alum used for the treatment, and after the heating process, a lot of acids are released. We found the presence of sulfuric acid. So and sulfuric acid, it's a strong acid that could start the degradation of the wood. This is the pH of the object nowadays, which is very acidic. Here some picture collected by ACM, which is a scanning electron microscopy, and some maps that helped us to better understand the distribution of the alum within the wood, and elemental characterization. As you can see, there are some signal of oxygen, aluminum, potassium, sulfur, and carbon, of course, from the wood. And here, these nice crystals, well-formed crystals. Crystal is due to the presence of the alum. This is the typical shape of crystal, alum crystal. So, in order to neutralize, to adjust the pH of these artifacts, we decided to start the experimentation of nanoparticles, alkaline nanoparticles, synthesized in Florence at CSGI. They have this shape, hexagonal shape, typical of calcium hydroxide, which is a strong base. And the idea was to neutralize the sulfuric acid presence in the wood using these solid particles. The reason why we use solid particles was because using a solution of an alkaline solution that could be too strong for the wood, because alkali solution are harmful for the wood as an acidic solution. So we decided to use a solid part to deliver the OH group useful to neutralize the acidity very slowly. So in order to don't be too aggressive to these poor objects. And we use the injection method. Here you can see some original Oseberg wood artifacts that are injected with the nanoparticle dispersion in isopropanol. And here some reaction between the main reaction we use to neutralize to better to understand the reaction between acid, sulfuric acid, nanoparticles gives you a stable environment within the wood, neutral environment. So these are some pictures collected by SEM, and because after here you can see there is this crystal which is called its famous gypsum. It's the famous gypsum, and we decided to monitor the behavior of these crystals after the treatment, and we started in 2016 using electron microscopy. And as you can see, this crystal formed after the treatment are covering the alum crystal. These are alum crystals, and these small white spots, brighter spots, are due to the gypsum distribution. So we are comparing every year more or less the behavior of this crystal, because we don't want to create stress. We don't want to this crystal to grow, creating stress within the wood. And this is the museum where these objects, part of these objects are displayed. The Oseberg ship, which is which is the I showed you in the previous slides, and the three sledges displayed nowadays. And this is the end. Thank you.
That was very interesting presentation, Fabrizio. And when I'm from computer science background, and it was like very exciting to see like things about Egyptian, like how to preserve this kind of heritage items. So I'm looking at comments from the audience, but I haven't seen any comments yet. Oh, so maybe like in the meantime, you can give us some one or two interesting facts about the topic, which is not in the presentation.
Yeah, thank you. About the actually, should I say now, or should I wait till the end of the now? Okay. Some interesting facts. It's actually, I don't know if it is an interesting facts, but the ship was found accidentally by a farmer who was just trying to he was walking in this farm, and he found this mound. Uh, so he didn't know actually that there was a ship. He just wanted to work in his farm. So, and was actually, he didn't realize what he was gonna find in his property. And actually, so this is just an accidental discovery. So
Yeah, it's really interesting, and it seems like
mhm,
always luck plays certain role in this kind of discoveries. And we also got
mhm.
some comments from the viewers. Like the first one is from Lou. It's like the comment is they are like she's basically asking, was there any other common material apart from wood that you find in the excavation area?
Was mainly wood actually. There are some part metal objects, but connected to the wood, some pins, screws, some yeah, I don't know if there are some other sorts, but I don't think so. For what I know, more than hundreds objects found in this burial mound were made of wood, and the only metal parts are connected to this wood. So mm, 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 mm. They are like, yeah, pins and screws. So not that is the main material. It's actually wood. Mm, 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 mm.
And we have one more question from the same viewer. It's like, so how small does it need to be your sample to be able to like work with it?
depending on what you want to do. For characterizing, for instance, the if the treatment worked, like because the topic is to neutralize the acidity. If you want to neutralize it, you applied an amount of a certain amount of nanoparticle, and so you want to measure the pH before and after. In order to do this, you just need a few milligrams of object of coming from the object. The idea is to apply this technology, this methodology to the object. So after doing this, all the experimentation, all the analysis, and when we are sure of the methodology, we will apply to bigger objects. So also, for instance, for those SEM pictures, the scanning electron microscopy, I used for those kind of measurement fragment of like 1 square centimeter. So they are very, I mean, they were quite big, 1 centimeter. You can also use an even smaller amount. So the instruments are very sensitive, so you don't need uh, you don't need a high amount of sample. Like in the range microns from yeah, millimeters, from microns to up to milligrams. Sorry.
Yeah,
Yeah.
that's really interesting. We also have like
Mhm.
one more interesting question from Andrew. Basically, the question is about like what was the rationale behind injecting alkali rather than soaking the wood in it?
That is a good question. Thank you. Because since there are some pros and cons, no, in using this kind of methodology. We didn't want to use a solution because they were too strong and too aggressive for the object. So we decided to use this dispersion of solid tiny nanoparticles in isopropanol, and but they are solids. They are not solution. They are not ions. So the and since the and due to this fact, the penetration was hindered by the I don't know, some objects are covered uh, by linseed oil, by the epoxy resin. So in that case, we cannot remove resins or linseed oil, and we decide to, instead of use the soaking method, we decide to directly inject the nanoparticles within the wood because of penetration problem. It's we already did. We started actually with the by spray, by brushing. We used also soaking by immersion for 2 weeks, like several days. But we saw that the penetration wasn't so good. Nanoparticle could penetrate more or less 1 centimeter, but in case you have a sledge, in case you have I don't know, some big object, we cannot immerse an entire a whole sledge in the tank. So we decided to go for injection. Yeah, for these two reasons, because the object, bigger object, cannot stand a big buff, and because of penetration problem issues.
Yeah.
Yeah.
Yeah, I think the answer is very clear, and it should be
Mm-hmm.
like easy for that, easy for Andrew to understand. And we also have like two more further questions. I think we are a little bit running out of time, but I think you can handle it. But the both the questions are like almost about the same concept. The first question by Francisco is about like, is it a common thing that would not decompose after all those centuries underground? And it's like same question has been like asked by Alexander as well. It's Like, how did wood survive for centuries? Did Vikings use some organic oils to protect the wood?
No, it's no, actually, no. Was just depends of the environment, and fortunately, that area was made of blue clay, and so this ship was covered by this clay, who provided an oxygen environment. So the main problem is when the oxygen is in the site, no, and in this case, the environment was there was not oxygen, so a microorganism couldn't live in that environment. So was well preserved mainly because of the environment. And the same, for instance, the Vasa ship in Sweden um, was well preserved because was sank in the sea. The problem starts when you excavate the finds, and when there is a difference between these two environments, oxygen and non-oxygen. So in presence of oxygen, that starts the degradation. The problem is oxygen. So for
It completely makes sense to me. So
yeah,
I think it should make
yeah,
sense
yeah.
to others as well.
So,
I think
so it wasn't because Vikings were so smart to use to use organic oils to protect the wood, because also organic oils are organic as the wood. So was just accidentally was a good ground made of blue clay. So who covered the ship from the oxygen for more than 100 years. Sorry, 1,000 years. Yes.
uh, I think we are still on time, and like, yeah, there are no more questions. So yeah, I think we are exactly on time. Thank you, Fabrizio, for your
Uh,
wonderful talk. And
Thank you.
viewers, like, if you have any question, like Fabrizio will be like ready to answer in YouTube.
Thank you. Thank you again to Pint of Sign organizers.
Okay, Maria, the stage is
Okay.
yours.
Yes, that was awesome. Yeah, so I think we are ready for our next speaker, Hugo De Boer. And we would like to welcome him. And Hugo is a professor and acting head of research and collections at the Natural History Museum, University of Oslo. Hugo leads the European project Plant ID on molecular identification of plants and the 4Bio Research School on Biosystematics. He is also involved in projects related to medicinal plant use in the age of Europe exploration and DNA from the environment. His research focuses on molecular identification of processed plant products in trade, specifically of monitoring of cross-border trade and automated species identification. Hugo is passionate about student supervision and career development, and he has enabled many aspiring students to develop their specialized and transferable skills for careers in science and beyond. Today, we have the pleasure to hear from Hugo all about wild orchids, their use in society, and how this trade and this issue may threaten their conservation. Remember that if you have questions for Hugo, you can post them in the YouTube chat and he will answer after his presentation. Welcome, Hugo, and thank you for joining the Pint of Science Festival.
Thank you, Maria, for this introduction. Let me just share my screen. All right, this is taking some time to load, not unexpected. So I'm Hugo De Boer, as already been introduced by Maria. Here the slideshow has popped up, at least for me it has. I'm a researcher at the Natural History Museum. I'm a pretty regular guy, actually. I like to wear funny hats. And I spend more time behind my computer than behind a microscope. As a scientist at the museum, I study biodiversity in all shapes and sizes and add things to my hoard, my museum collection. But back to my talk, eating orchids and illegal trade. And back to this picture of Basset and me in funny hats. What do you think of when I say orchid? Do you think of those flashy orchids at Bangkok airport? Or maybe that green wilted stalk that you have at home that you got as a present from someone who'd been on a shopping spree at IKEA? Well, orchids, they come in many shapes and sizes. There's actually about 30,000 different species of them. More species than any other plant family. When I talk about orchids, it's also important to realize that orchids, they cannot be traded without specific permits. All orchids are regulated by the Convention on International Trade in Endangered Species of Wild Fauna and Flora, a treaty that's been effective since 1975 that regulates trade in ivory, tiger skins, pangolin scales, but also orchids. And this is my hook for illegal trade. No orchids can be traded without permits. But now back to eating orchids. From Albania to Iran, some people eat orchids. Specifically, those orchids that grow on the ground and make small potato-like tubers. Here, I'll show you what they look like. These are the potato-like tubers of an orchid. These little orchid tubers, they're called salep. And they look a little like shriveled, hairy raisins, right? And here it's maybe worthwhile to digress, because the orchis comes from the ancient Greek and means testicle. And if we look at these things and we think of the ancient Greek meaning of the word orchis, then we realize that there's some similarity. Well, so how do people eat these orchids then? Well, they harvest the orchids, so you pull out the plant from the ground and you get these little potatoes, you dry them, and you can grind them into a powder. And this powder you can make into a warm drink, such as salapi, which is this man is selling on the streets in Greece, or here, as these people are selling it in Turkey. It's a very warm and flavorful drink, a little bit like hot chocolate. You can also make it into a type of ice cream called marash dondurması, which is a very sticky type of ice cream. And you can see here how you can pull these long strings of it. That is because the orchid tubers, they contain a polysaccharide called glucomannan. And this glucomannan yields this texture. So where do these orchids come from? And how can slow growing and uncommon species like orchids support such massive consumption over a long range and time. One such place are the Kopet Dag Mountains, straddling the border between Iran and Turkmenistan, on the far side of the Caspian Sea. And it is here that my colleague and I went undercover in our funny hats to find out where these tubers come from and how they are traded. In order to do this, you need to talk to local people to understand the drivers, the economy, and the sustainability that the collectors have, that the middlemen have, that the traders have, that all people in the supply chain have. Because there might be many different reasons why people collect these orchid tubers. Of course, many of them are monetary. On my fieldwork, I also brought my daughter along, as you can see here. She is very fond of bird watching, so she enjoyed this trip. Anyway, after studying orchid collection for a period in Iran over a course of several years, we found out that millions and millions of orchids are harvested annually in Iran alone, and that most of these are exported to Turkey through the Kurdish Autonomous Region in northern Iraq. So, if you're able to draw that conclusion, then you might decide, how about that? Or you might decide we need to save orchids. Or there might be a very geeky part of you that thinks, yes, but what orchids? Which species are actually being collected? Which species are being affected most or more disproportionately than others? And that is exactly what I went to study. If you want to find out what orchid species are in these bags of tubers in the great bazaar of Tehran, then you can use a very simple method called DNA barcoding. DNA barcoding is a method from which you can take DNA from an unknown species and compare it with known species. It's a bit like fingerprinting, it's your CSI, the CSI of plant identification. If we look at it a little bit more in detail, DNA barcoding works like this. You have an unknown organism. Obviously, always some animal takes the show, but in my case, I study plants. So here we have to imagine that that little bug is actually an orchid tuber. We extract DNA from that. We amplify specific targets that we want to use for identification. We sequence that DNA, and then we have a DNA sequence originating from that unknown tuber, and we can compare it with a database of sequences from known tubers. And we can match them, and then we have an identification. So if you want to do that in Iran, for example, then you can buy orchid tubers everywhere in marketplaces, but you also need to have a reference database of properly identified orchid species, extract DNA from those, and use those as a reference for your identification. And this is where a museum comes in very handy, because museums around the world have massive collections of plants. And here we can plot all of these collections on the map, and we can see exactly where the different orchid genera occur in Iran. So combining our reference database together with the sequences from the tubers that we bought in the marketplace, we can identify exactly what proportion of tubers come from what genera. And we can see which genera are more affected than others by this trade. And these genera and these species, we know where they occur in Iran. So then we can also pinpoint exactly what areas there is a lively trade in species and where they are collected. And maybe we can identify national parks or protected areas that are being targeted, or maybe we can discover new areas in which we did not know that orchids occurred, where they are coming from. But back to this man selling his drink. That drink that he's tapping there into that cup, there we cannot identify the orchid tuber that was put into it, but we might want to know, because we don't really know what species go from the market to the products. Of course, that product is made out of a powder of orchid tubers, but also maybe many other plant species. So the DNA in that cup is a complete mixture of different things. It's very hard to use DNA barcoding for that. But fortunately, there's an alternative method that we can use, DNA metabarcoding. And we applied that method to uncover what orchid products are being traded and sold in Iran, Turkey, Greece, and Germany. If I take, for example, an ice cream made of salep, we can see in bold font the orchid species that we found in that. 0.1% of the DNA that we sequenced from that product was actually an orchid, whereas 98% of it was a different species called Siamopsis tetragonaloba, which might mean nothing to you, but it means a lot to a person producing foods, because it's guar gum, and it is a type of gum of plant origin that will create a very similar texture to the real orchid glucomana. So here we see that not all that glitters is gold, and not all salep actually contains orchids. Also, if we take a look at an instant salep, so like a little powder that comes in little satchels that you can buy in the store, it does not actually contain any orchids at all. The main ingredient here, again by its scientific name, is rye. And of course, rye is also a starch-rich thickener that can be used to make a creamy texture to a drink. Anyway, after going through many of these products and analyzing them, we find that a lot of them do not contain orchids, but there's also a significant number that do contain orchids. All of these are illegally traded orchids, and all of them are illegally harvested because they are protected in each of the countries in which they are traded. So looking at this last picture, we see the different coffee cups or the different salep cups from the countries where we did this study. So we have a cup in Iran, in Turkey, in Greece, and in Germany. And we can look at the figure on the right, figure B. We can see that in Germany or in Turkey, if you buy salep, that there's a good chance that you are buying a product which does not contain orchids. Whereas in Iran and Greece, chances are better that your product actually contains orchids. And if we look at the different categories of products on the left, we see that maybe a powder or a processed drink, that it's a hit and miss 50-50 chance that you're actually buying something with orchids in it. So to summarize, I want to show you that salep products have a very diverse range of qualities. Some contain orchids, and that is bad because orchids are protected species that are not supposed to be harvested indiscriminately and traded. Some do not contain orchids, and that is also bad because then you're being cheated. You're buying a product in good faith that is supposed to contain an illegal ingredient, and it doesn't. So either you're eating unsustainably wild harvested orchids, or you are eating a mislabeled cheap substitute. So I hope that I've been able to show you that orchids are more than flashy houseplants, that orchids are important in culture and in cuisine, especially in the Eastern Mediterranean, that orchid collection is unsustainable and a threat to the survival of these species in the wild, and that using DNA and museum collections, that we can study conservation and illegal trade issues, even with the collections that we have here in Norway, we can still understand novel aspects of a trade occurring very far away. I hope you like my talk, and if you have any questions, I'll be glad to respond to them.
Hi Hugo, it was like wonderful presentation. I have like never heard about this salop before, but now I got to know it contains like lot of materials which have been like gathered illegally. And yeah, we also have questions from the audience. The first one is from Francisco. I never thought of Germany as an ex-Ottoman country. You involved it because of the strong Turkish community there. I'm not sure whether it is relevant
Yes, it's very
to
relevant.
discuss.
Thank
Okay.
you, Francesco, for this posing this question. Yes, it's the Turkish diaspora that has Turkish shops, of course, also in the Netherlands, also in other countries, and these shops, they stock salop products, and because people are largely unaware that salop contains orchids and that trade in orchids is illegal. We were interested to see whether these shops had salop in the first place, and then whether that salop actually contained orchids or not.
Yeah, that was a good answer. And I don't think we have any more questions. So maybe like, yeah, he said thanks. And there is one more question from Daria. Daria, yeah. Have you ever tried orchids yourself? How do you describe the taste?
That's a very good question, Daria. I have actually, because I'm really interested in the things that I study. Also, I grew up in Amsterdam, and there we also try everything that we can buy in shops. So in Albania, I tried some nice salop, and it's good. The glucomannan gives a thick, creamy texture to the drink. And the tubers, the orchid tubers themselves, they have a bit of an earthy flavor. It's a bit like the smell of fresh soil, and that gets into your drink as well. So it's a very particular flavor, which is hard, I think, to emulate with a synthetic alternative, because obviously glucomannan, it's also, you can synthesize it, and then you could make artificial salad, but the artificial salad wouldn't have the same flavor. It would have the same texture.
That's nice. We also have like one more question. I think that's similar to your answer. The answer you have provided. Like, is it technically possible to grow these orchids in artificial plantations?
Yes, it is. Yeah, it's possible. It takes a bit of time, because the orchids, they grow slowly, and as they are growing, the tubers get larger and larger. So the longer you wait, the bigger the tubers will be. So you're talking about maybe a 5-6 year cycle, and that makes it relatively unattractive to commercially grow them. But if the prices go up, right now for a kilo of real salad tubers, you pay maybe 100 euros. So there's definitely money in it, but I don't think it's that much money yet that it's that it pays off to cultivate them.
It's really nice to know, but I think maybe some people can try to grow it and see how it works. And I don't think we have any.
It's a very good question, because this is the obvious, the no-brainer, right? So why would we
Yeah,
harvest it in the wild? Can't we just grow it? And yes, we can grow it, but it takes a bit of expertise. Something needs to be developed. Also, we've been looking at maybe we can create an artificial cross or a hybrid that grows faster, produces a larger tuber. But then that might help the orchids, but it doesn't really help for the local people whose livelihoods depend on collecting the orchid tubers right now.
Yeah, yeah, I also agree with it. It's always like if somebody else grows, then like somebody else will like there are other party who affects because of it.
Yeah.
Yeah, I think we still have like 5 more minutes. Okay, I mean, yeah, there are no more questions. Then maybe like I get to ask some question, one or two. Mm.
All right.
Yeah. So yeah, if I have to ask, okay, let's see.
Wait. So wait, Brain. I can tell you something. Maybe you know, because this is something that you asked from Fabricio as well.
Yeah, okay, yeah. I was thinking of not asking the same thing, but yeah, if you are interested to tell something interesting about this, then you are always welcome.
I have. Um, you know, the salep was long perceived as a medicinal plant, and because people thought that if you would drink it in the fall, it would protect you from having a sore throat. So it's been part of you know, of the European pharmacological pharmacopoeia as well. So pharmacy students up to the 1960s and 70s in many European countries, they had to be able to identify salep tubers and to distinguish them from other species, because it was part of their training, of course, not only to know medicines and what they were used to, but also to identify raw plant materials that were used to manufacture the medicines. So actually, the University of Oslo, but also universities in Denmark and Stockholm, they have large collections, glass jars full of salep tubers from the 1900s, 1800s. And it's really interesting to see if we can identify those and find out more about which species were used back in those days.
Yeah, it seems like really interesting. And we also like one more question. How does DNA survives in ice cream?
Yeah, thanks, Lourdes. That's a good question. I don't know, but DNA is really hard to destroy. Especially if there's no, you know, no specific DNA degradation activity or high temperatures, it will actually last quite a long time. I was also thinking of, you know, the Oseberg ship that we were hearing from before. There they found the DNA in bones that were part of the offerings. So that's DNA that's been preserved for 1,000 years. So surviving in an ice cream must be easy compared to that.
Yeah, I think it should be like, yeah, I mean, if it works in the ships and other things for thousands of years, then I guess it should work with ice cream and stuff. Okay. Thank you, Hugo, for your wonderful talk. I think Maria will take over now.
Maria, you are muted.
Maria, you have to unmute your mic.
Here we go. Yes. Yeah, thank you very much. Yeah, it was very interesting to hear about the orchids and how our consumption might be threatening them. It's very important to hear this information. Yes, and now we arrive to the end of this night. And after Hugo's presentation, I would like to wrap up this first night of Pint of Science 2021, the Oslo chapter. And yeah, we want to thank again to all the volunteers for all your efforts in brewing this amazing first night. Everyone here deserves a big applause and a big pint of beer. And as well, we would like to thank to all our volunteers and our sponsors for supporting this edition. And we hope to see you tomorrow at 6 p.m. For the night Waves of Radiation. Thank you all for coming, and have a great night.
Hello. So before we wrap up, we are going to do a quiz. So I hope you were paying attention. And there will be a prize. So if you do have the top score, please stick around and let us know your information. I don't know what the prize is. It's a surprise, but it's going to be something cool. I have an idea of what it is. So I'm going to share my screen. Share screen. We practiced this once. That one. Yeah. So now, there you go. Okay, cool. So either go to kahoot.it or download the Kahoot app and enter in that pin. So I'll give everyone a couple seconds to do that. I don't have any way of telling who's in here. No, I do. There are currently 0 of you. So why don't you go ahead and join on the Kahoot page or on the app. And I'll tell you the questions tonight have to do with the 2 talks. So we got some Viking and Norway history. We have some orchid questions, and I threw in some other sciencey questions too because I felt like it. I don't know. There's some general science questions in there as well. So I'll give a couple more minutes. I am looking forward to finding out what this surprise prize is. That's going to be really cool. We got 6 of us in here already. Give her a couple more minutes. Well, I was expecting a few more, but that's okay. We're going to have the 6 of you, and you will compete for a prize. Now, one thing to remember on Kahoot as well is you get more points the faster you answer. So it's not just getting the correct answer; it is getting the correct answer quickly. That's sort of the tiebreaker. So keep that in mind. Definitely read the questions. I will read the questions out, but as soon as it pops up, you are welcome to answer, and encouraged to, because you'll get more points if you answer quickly, assuming you're correct. So there's 8 people now. Let's go ahead and get started. So Pint of Science presenting. First question coming up is a quiz. So the question is, why is plant identification important for society? Detect adulterations, you can trace illegal trades, conservation, or all of the above. 10 more seconds, get your answer in. And if those of you who didn't jump in, you can still join the game at that pin at the bottom there. And yeah, all of the above. All right. Next oh, there's the scoreboard. All right, we got a tie for first place. As you'll see, there was the score is determined by your speed of answer. All right, let's see what's the next question. I think it randomized. All right, so this is not related to our talks. This is one of my questions. Which of these is not a property of elementary particles? Flavor, color, smell, or charm? Remember, not a property of elementary particles. This is looking back at my physics undergrad days. It just seemed like a fun question. Nothing to do with today's talks. That is good. Well, we only got one. Yeah, so charm is a property of elementary particles. You got charm and strange and up and down and top and bottom. You have different colors, you have different flavors, but there's no different smells. So we got a little change, FN jumping to the lead. Okay, this is a true or false question. Vikings wore horned helmets. This is false. Despite what Wagner would tell you, horned helmets are actually really terrible for fighting. You have this thing sticking out the side of your head, you get hit by a sword, it's going to break your neck. Never actually happened. There's no evidence that they ever had one. Let's see what the scores are now. FN is apparently on fire, taking commanding lead, but Science Nerd is catching up. Yeah. All right. Next question is another 4-point quiz. Which of the following drinks or foods contain orchids as ingredients? Lasagna, soda, vanilla ice cream, or a mimosa? All right, time is up. Someone got in right at the end. Yes, it is vanilla ice cream. I suppose there are some sodas that might have vanilla in them. I'm somewhat disappointed that no one guessed lasagna, although I guess that was a particularly obvious wrong answer. But yeah, vanilla is a type of orchid, and it's pretty common in our cooking. All right, and FN. Well, Science Nerd is catching up, and then we got a couple other people in here. All right, next question. How many of the roughly 1,000 stave churches erected throughout Norway during the Middle Ages have survived today? 150, 12, 430, or 28? Yep, the answer is 28. Of those 1,000 churches, many of them simply degraded, some of them were attacked, and many of them recently were destroyed by death metal cults. So fascinating history of Norway there, but yeah, you can go visit them. They're quite pretty, and they smell nice. Ooh, oh, Science Nerd is catching up. I think there's still an opportunity. We are, I think, halfway through. I think there's 10 questions. So there's definitely still a chance to catch up. Science Nerd is still on fire, but is dropped out of the lead, or is catching up pretty quickly. All right, how can you identify a plant? Looking at the shapes of the leaves, by the DNA, by the aromatic compounds, or all of the above? All right, and the answer, of course, is all of the above. Some of you weren't paying enough attention during that talk. But yeah, as we heard in that talk, you can identify a plant through all of these things. Scores are getting up there. Still a lot of contention in there. There are, I think, 4 more questions left. So definitely still anyone's game. How many UNESCO sites does Norway have? Norway has some of the densest population of UNESCO sites of any country in the world. They're pretty cool to come visit. All right, and the answer is 8. I can't name all of them, but they're pretty cool. I've been to a few of them. All right, mixing things up a little bit. Lav catching up. FN still in the lead. All right, last couple questions. How many orchid species are officially recognized? Over 28,000, about 15,000, over 1,000, or about 100,000? Like I should have checked these questions a little bit because there might be some technical overlaps. Yep, over 28,000 1,000. Quite a few different orchid species. Lots of diversity in that. Let's see what the scores are. All right, still anyone's game here. And let's see, second to last question. This is again from me, not to do with the talk, but when was the oldest known prosthetic made? As prosthetic leg or arm or whatever. I think in this case it was a toe. 1400 BCE in China, 950 BCE Egypt, 300 CE Rome, or 1400 CE Mexico. Pretty sure it was a toe. I don't think that actually helps anyone. But yeah, it was in Egypt. We found it in a mummy. You can see behind me, I studied prosthetics. That's why this question is in here. Now this next question, let's see, going into the last question. Ooh, Lav. We have mixed things up, so I think it's still anyone's game here. The next question, you should know if you have been following our science facts of the day. This is my favorite random science comment. How many peas would fit in the observable universe? 10 to the 14th, 10 to the 23rd, 10 to the 87th, or 10 to the 121st? You can thank an afternoon playing with Wolfram Alpha for me knowing this question. The answer. And the answer is 10 to the 87. 10 to the 87 peas can fit in the observable universe. I guess no one really was following our our facts of the day because it seems to be a random distribution. But yep, that's a lot of peas. The universe is pretty big. So the winner is Science Nerd in third, FN in second, and in first place, Love. Thank you so much for playing. Please get in touch with us so we can send you your present. I'm going to stop sharing now and throw it back to Maria. No? Am I the only one still here?
Yeah, no, you're not alone. I'm here.
I'm all alone. Yeah, so thank you so much for playing the quiz. I enjoy it. I hope you enjoy it
too.
And yeah, please get in touch with us so that we can get your contact info so we can send you a present. And I will sign off.
Yeah, thank you so much, everyone, for joining this night. Bye.
Bye, everyone.